Well, class, today we're going to look at motion graphing. Yesterday you determined speed, velocity, and acceleration. Today we're going to look at how to graph those things. Because we are going to have graphs up on the screen, most of the video you won't see my face, so you have room to look at those graphs. Now, a few questions we need to make sure you can answer by the end of this. Can you measure and graph changes in motion? Can you interpret an object's motion from a graph? And can you describe the characteristics of a motion graph? So we're going to look at a speed graph or a velocity graph. They're basically the same thing. And then an acceleration graph as we go through it. And so I'm going to go ahead and click me away, and then we'll keep going through this graph. And so you see these are several different types of speed graphs going on here. And so we see here there's some constant speed in these straight lines. There's changing speed in these two that curve. And so a typical speed graph will have a distance or position on the y-axis and time on the x-axis. So remember, any line graph is a change over time. And so time's always going to be on the bottom there. Graphs help us make motion easier to picture and to understand. You can kind of see what's happening based on the graph once you learn how to read the graph. And the lines represent an object in motion or speed. And so we're going to look at several of those in this. Make sure you understand the difference between them. So a constant speed is when the speed of an object remains the same and it does not increase or decrease. And so if you look at 60 miles in 60 minutes, that's 1 kilometer a minute, or sorry, 60 kilometers in 60 minutes would be 1 kilometer a minute. 40 kilometers in 40 minutes would be 1 kilometer per minute. And so as we go up the graph here, you see 40 to 40, 60 to 60, the speed has stayed the same. And so when you're reading 60 kilometers in 60 minutes, that's the exact same speed as 40 kilometers in 40 minutes. They're both 1 kilometer per minute. If there's no speed, you're going to see a straight line across. Because you see, over time, the distance didn't change. And so if we were looking at a longer graph, maybe they got up to 40 miles and then they stopped. The object is at rest. So this would be like stopping at McDonald's for lunch on a trip that you're going somewhere. Time changes, but the distance stays the same. So a straight line means that there's no distance, and so there's no speed. It's at rest. It's still. So get with your table partner right now and discuss the following task. In your own words, describe the motion of the object shown in the graph. What happens here between 0 and 10 meters? Then what happens during this time here from 1 second to 3 seconds? And then what happens again right here as it goes back up? So take a minute and discuss with a partner what's happening on that graph. If you're not sure, you have questions, make sure you're asking a teacher. Okay, let's look at other types of graphing motion. Velocity is speed in a given direction. And so if you look at line A, it's moving away from point 0, the origin. So the distance is going, let's say, north, maybe over time, and then it turns and it goes back south. And so the velocity has changed, even though the speed stays constant. And so that time, the distance they're traveling, the amount of time is staying the same, but the velocity changes as you go back to the point A. So this might be like driving to the store, driving back home. If that speed, the average speed stayed the same the whole time. So get back with your partner again and discuss the following. In your own words, describe the motion of the student shown in the graph. And so what was happening at all of these points along the graph? Then when we talk about acceleration, acceleration is a change of speed or velocity over a specific amount of time. It's a curved line, typically, and the steeper the incline, the faster the acceleration. So as the distance and time here, we're going to see that it accelerated when it went faster. It was kind of a constant speed, and then it started going up a little bit, and then it went up a little bit more. You see each one of these little kind of curves in the line is showing an increased speed, so it shows that acceleration was happening in that graph. Now notice all of these that we've looked at so far are distance versus time graphs. And so we see acceleration because we see that curve that happened. We're going to look at also acceleration graphs, which is going to be velocity versus time. And so they're going to be a little bit different. You got to pay attention to what is it that the graph is showing, and what are you graphing if you're the one doing it. And so you see these different types. There's a constant speed going fast. The distance is increasing in a short amount of time. There's a constant speed going slow here. The distance is increasing, but not as quickly. And so you see for these two to get to the same spot, it took a lot more time for the purple one. On this velocity graph that's showing the direction, so it got to a certain spot, it stopped, took a rest, no distance changing right here, and then it went back to where it came from. And so the velocity changed. And then an increase in acceleration as it curves up. All of these are distance versus time graphs. So now we're going to look at a velocity versus time graph. It's a little bit different because on this side, we no longer have distance, we have velocity, or that speed. And so we're measuring how the speed changed over time. In the typical acceleration graph, you'll have speed or velocity on the y-axis and time over the x-axis. The lines represent the acceleration or velocity. Remember, no longer are we measuring distance. We're measuring that speed. So let's look at some. In these, if we have the time here at the top, and then what was the car doing? When the velocity of an object remains the same, its rate of change does not increase or decrease. So on a velocity versus time graph, the car is moving at 10 meters per second. So it's moving the whole time. This straight line no longer means that it's still. It's moving at 10 meters per second the whole time. It just doesn't change. And so you have to pay attention. What type of graph am I looking at to be able to know what this line means? Be very, very careful with that, because on the other ones, this would mean at rest. At this one, it means the same speed. If you're looking at a constant acceleration, the speed is going up, or the velocity is going up at the same rate for that entire 5 seconds. Acceleration is constant at any point on the line. It's going to be a straight line going up. So at 4 meters per second at 1 second, if you brought it right here and came across, 4 meters per second at 2 seconds, all right? The steeper the slope, the greater the acceleration. And so you need to make sure you're watching carefully. If it's a straight line, that acceleration is constant. It's going up at the same rate. Increasing acceleration, a curved line indicates the acceleration is not constant. And so in this, you see, if anytime you see that curve, down here it's accelerating slower. Once it gets up here, it's accelerating faster. A car starts moving slowly and then gradually increases in speed. And so you see that going off from a stop sign or a stoplight. That acceleration, that curve goes faster. The steeper the line, the greater the rate of acceleration. So get with your table partner and discuss the following task. In your own words, describe the motion of the student in the graph. What was happening along these points in the graph? So actually take the time to do this to make sure you understand. Don't try to speed through and just get things done. Take the time to understand what's here. If you don't understand, make sure you're asking questions so that you can figure out what's going on in these graphs. So here's a different accelerations happening on this graph. We have velocity on the side, on the y, time on the x. See a straight line. It's constant acceleration. It's going up at the same speed the whole way. All right, or the same acceleration, I'm sorry. It goes up the same acceleration the whole way. Straight line is a constant speed. That's where it's the same speed all the way across. And then a change in acceleration is going to be this curved line here. So with your table partner, on a graph paper, I want you to make up 2 different scenarios and graph them. You must create a speed graph and an acceleration graph. So I want you to come up with a scenario. There's graph paper up on the table. Come up with a scenario that's going to demonstrate changes in speed and changes in acceleration. Explain that scenario and then graph it out on your paper. And so you have that, you have the assessment you could be working on. And so I want to make sure you understand, how do you find speed, velocity, and acceleration? What are the measurements for those? And how do you recognize those on a graph and then graph them yourself? And so you've got quite a few things to make sure you understand before you're done today. Once you think you got it all, I want you to call a teacher over, let us look at it, and make sure that you understand it the correct way. And then I want you to be sure on your graph to label everything on the graph and describe in sentences what is happening on each graph. So I want you to be able to do that before you finish this section on graphing motion. So things to make sure you understand and can do. Make sure you can interpret the object's motion from the speed and acceleration graph, and then you can describe the characteristics of that graph. So make sure you are able to do those things, and then you'll be ready for the quiz when it comes up.